All right, so we are on 7.02 today for geometry, and we're looking at our quadrilateral family tree. If I can get a good window here. So we're going to talk a little bit about how all these shapes are related to each other, which you guys have been seeing now for quite a few years since elementary school. So first, our top of our tree is our quadrilateral, which we know has 4 sides, very general. We know there's 360 degrees in all of the interior angles. Then we can go down to our trapezoid over here. So a trapezoid has at least one pair of parallel sides. So pretty general, just has to have one pair of parallel sides. It used to have a different definition, but when they switched to Common Core, they changed that definition so that it has at least one pair of parallel sides. And that'll be for when you do the trapezoidal rule in calculus. But for our purposes, trapezoids that we've always seen before that have exactly one pair of parallel sides, those are still trapezoids. It's just that this now includes more shapes as well. So a parallelogram is a type of trapezoid because a parallelogram has 2 pairs of parallel sides. Pairs of parallel sides. It also has those opposite sides congruent, both pairs of sides parallel. Opposite angles will be congruent in a parallelogram, and your diagonals will bisect each other. Okay, so we also know that from a parallelogram, we have a rectangle and a rhombus. So what happens as you go down the tree is these shapes here, so a rectangle still has all the properties of a parallelogram. So it'll still have, there's 5 of them. So it'll still have both pairs of opposite sides congruent, both pairs of opposite sides parallel, opposite angles congruent, consecutive angles, so angles next to each other, will be supplementary. And the diagonals will bisect each other. But then we add on a couple more to rectangles that all the angles are going to be right angles. All right angles. And we know that your diagonals are going to be congruent in a rectangle as well. Now in a rhombus, again, it has all those 5 properties of the parallelogram. And then in a rhombus, we know that all 4 sides are congruent. We know that the diagonals are actually going to be perpendicular to each other. So that's a really important one. That's unique about the rhombus and the square. And the diagonals will also bisect those angles as well that they cut through here. And then our square, kind of like our inbred child, if you think of it as a family tree, came from the rhombus and the rectangle. So the square has all the properties of the rhombus, all the properties of the rectangles, and all your properties of your parallelogram as well. So for a square, you've got congruent diagonals, diagonals that are perpendicular, diagonals bisect each other, all the things that are true about all the things that come before it. Over here, we didn't talk about our isosceles trapezoid yet. That is a trapezoid, but you would have your non-parallel sides would be congruent. And your base angles will be congruent. Now in a trap, you actually have 2 bases, so both pairs of base angles would be congruent. Opposite angles will be supplementary here. And that's because these are parallel lines. So you've got same side interior angles will be supplementary, and your diagonals will be congruent as well. And the last one we didn't talk about was your kite. So your kite has no parallel sides. And your opposite angles will be congruent in a kite. Your diagonals will be perpendicular, just like in your rhombus. These will be perpendicular, they'll form right angles. And you will have 2 pairs of adjacent sides. that are congruent. So these two are congruent, and adjacent just means next to each other. Okay, so no parallel sides. Okay, so that's just kind of the setup and how they relate to each other, which is important to help you remember the properties. Because like if you remember all the properties of a parallelogram, and then you can remember what comes after the parallelogram, you know that all of these have those same properties of the parallelogram. All right, so now let's just look a little bit more specifically at all of those properties. So first, let's talk about your trapezoid. So a trapezoid has at least one pair of parallel sides. For an isosceles trapezoid, you've got the non-parallel sides, which we call the legs. Those are going to be congruent to each other. The angles, you've got both pairs of opposite angles are going to be supplementary. Again, that's because you've got your parallel lines with same side interior angles, and then our base angles, both pairs of base angles will be congruent. In an isosceles trapezoid, diagonals are always going to be congruent to each other. Try to always, if you draw it out, sometimes you can kind of just see what looks to be true, and that can help you to memorize it because it is a lot to remember. Parallelogram. So for parallelograms, both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. And then your consecutive angles are supplementary. And again, here, if you know these are parallel to each other, because it's a parallelogram, then you've got consecutive angles here. Those are same side interior angles. So those are going to be supplementary. Same thing if you looked at the consecutive angles here and here. Those are also going to be same side interior angles, so they'll be supplementary. And then in a parallelogram, the diagonals bisect each other. They are not congruent in all parallelograms. You can see here, this one here looks longer than this one. A rectangle is a parallelogram, so all of those properties are going to be true. Plus, about the angles, it's going to have all 4 right angles, and the diagonals are going to be congruent. And then in a rhombus, you're going to have all the properties of a parallelogram, all the properties of a rectangle, and then in addition to that, you know that all 4 sides are going to be congruent. You know the diagonals are perpendicular to each other, like we were saying before. So they form right angles here. And we know that the diagonals are also going to bisect those opposite angles. So here, here, and there. So a square is a parallelogram, but it's also a rectangle. It's also a rhombus. And it's even an isosceles trapezoid. So all of the rules above would also be true for a square. All right, so now that we have all of our properties, and again, that's something you guys really need to study to really make sure you know, especially as we get closer to doing proofs with the parallelograms. You really need to know those properties of how to prove a parallelogram. All right, so now let's go on to some more examples. So these are a 7.02 geo notes. And we're going to talk about quads and more specifically parallelograms, which are quadrilaterals. All right, number 1. So you're going to just use your properties to answer all of these. And really, I want you guys to be doing these mostly on your own, if possible. And I'll help give you a few hints of things you want to always be looking for. So given Rome is a rhombus with a perimeter of 60 centimeters, if the length of its longer diagonal measures 24 centimeters, find the length of the shorter diagonal. All right, so for this one, and for all of these, most important thing I think is to always start off with a picture. So we're given a rhombus. When you label your rhombus, you want to always go clockwise or counterclockwise, but you can't jump, like I can't put R here and then O over here. I would have to go in order, clockwise or counterclockwise. It says the longer diagonal, I'm going to draw on both diagonals here. The longer diagonal is 24 centimeters. So if the longer diagonal is 24 centimeters, here's where I need to know my properties. In a rhombus, the diagonals bisect each other. So if the longest one is 24 and it's bisected by the shorter one, each side's going to be 12. I know the perimeter of this whole thing is 60 centimeters. And now I also need to know that a rhombus has 4 congruent sides, just like a square. And here the diagonals bisect each other. So I can take 60 divided by 4. That gives me 15 for the length of each side. And I want to find the length of the shorter diagonal. So if I can find just one piece of it, then I know I can double that to find the whole thing. So what else do I know about a rhombus? So go back to your properties and look at what we know about a rhombus. Well, the diagonals are perpendicular. That might be helpful. They also bisect the angles. We're not really talking about the angles here. And we already used that as 4 congruent sides. So let's mark off that they are perpendicular to each other. So does that help me? Well, now I know that this right here is a right triangle because this angle in the middle here is a right angle. So how do I find the missing side of a right triangle? Oh, I can use Pythagorean theorem. So let's call this side over here x. My hypotenuse is always across from the right angle, so that's that 15 side. So I would take 12 squared plus my x squared will equal 15 squared. So pause the video here, take a moment, solve for x, and then tell me write down the length of the shorter diagonal. All right, so you should have gotten your 225 minus your 144. You should have gotten x squared equals 81 plus or minus. So we get x equals plus or minus 9. Now we're talking about the length of a diagonal, so we have to reject the negative. So we just are left with x equals 9. We want to know the length of the entire short diagonal, so we'll do 2 times 9, which gives us 18. So the shorter diagonal is 18 centimeters. So a lot going on and a lot that you need to know to answer these questions. All right, let's try another one. So the following, or the diagram below, is a trapezoid with segment AD parallel to segment MP. And find x, y, and z. Okay. So these two legs here are congruent. We're going to call it A, D, P, M. I'm going to draw on my diagonal from M to D. And angle A is 110. P, that's our X. This is Y up here. And down here is 66 degrees. All right, so pause the video and see if you can use your property sheet to try to figure out your X, Y, and Z here. All right, so hopefully you were able to at least find a few things here. So we know that um, you've got consecutive angles here are going to be supplementary. So I could start by taking 180 minus 110, which gives me 70 degrees. So that tells me this angle right here must total 70 degrees. Well, I've already used up 66 degrees of that, so that means I have 4 degrees left. All right, we know that these two are parallel from the given. So if we trace our parallel lines with that transversal, we find that y must be 66 degrees. So we still need to find x. So we know y is 66, and, oh, sorry, z is here. I didn't get to you. So we still need to find x and z. All right, so since this is isosceles, I know that my base angle should be the same. So this angle should be the same as this angle. Well, this angle was 70 degrees, so this one must be 70 degrees. Likewise, up here, my base angles have to be congruent. So I know that 66 plus z must equal 110. Or you could have done these two, the consecutive angles are supplementary, so you could have done 180 minus 70 to get 110, and then set that equal to 110. You get the same answer either way. So go ahead and find z now. All right, you should have gotten z to be 44 degrees. All right. Number 3. ABCD is an isosceles trapezoid. If DC equals 34 and AB equals 18, find AD and put your answer in simplest radical form, SRF, simplest radical form. And here's your picture. Drop your perpendicular right here to E. And here's what we know. We know side DC we want to label is 34. AB up here is 18. And we want to find AD over here. So start really just by finding anything you possibly can. So, oh, and one more thing. AE is equal to 8. So that's all given information. So now if I want to find, I'll put that right here so you know that was given. AE equals 8. So now I'm looking for something to find. I see a right triangle, but I only know 1 out of the 3 sides, so that doesn't help. Now I know this is 18 and this is 34. What if I drop this other perpendicular right here? Then I know this over here would also be 18. Well, if I have 34 along this whole thing, and I subtract that 18, I'm left with 16. So I have 16 to divide between here and here. Now we were told this was an isosceles triangle. So if we know these are both 18, then what's true about these two triangles? Well, hopefully you realize these triangles need to be the same as well, because they have to have this same height if it's isosceles, which means these two pieces down here need to be the same. So if I have 16 to split up between the two, each of them is going to be 8. Now that gives me 2 out of the 3 sides in a right triangle right here. And how do I find the missing side of a right triangle? Pythagorean theorem, which comes up a lot in this unit. So the hypotenuse is across from the right angle, so let's call that x. So we always set it equal to the hypotenuse, so 8 squared plus 8 squared equals x squared. So that gives me 64. And I want you guys to pause the video and solve that, and I want it in simplest radical form. All right, your final answer should be 8 radical 2, and I should see your work for that. So I have x labeled, but I'm also going to put dA there to make it clear that I found that. All right, let's try another one. Find the value of x and y in the kite. So we know this is a kite given to us. So we know we have 2 pairs of adjacent sides, C, A, B, D, and this one diagonal is drawn in. Up here is labeled as 6x. We know these two are congruent. These two are congruent. Down here is labeled as y. This angle right here is 3x over 2 degrees, and this is labeled as a right angle. So segment CA is perpendicular to segment CD. And the rest of these are all angle measures. All right, pause the video and see how far you can get on your own for this one. Try to solve for x and y in this kite. All right, so for this one, you may have looked here and said, all right, if this, and this is even if you don't memorize your properties, you could see that this top triangle, CAB, should be congruent to CDB. We've got reflexive, we've got these two sides are congruent in these two, so they're congruent by side, side, side. Well, that doesn't help me find x or y because 6x equals y, and so I've got 2 variables. But it does tell me that these 2 angles over here would be corresponding angles, and since they add to 90, each of them must be 45 degrees. So now if you focus on this top part of the triangle, then you have all one variable. So I know 6x plus 3x over 2 plus 45 all will add to 180 degrees. So again, I got that by just looking at the top of this triangle, seeing that all 3 angles, they form a triangle and they're all in one variable, which is x. So now go ahead and solve that. I would like to get rid of that fraction, so I'm going to multiply the whole thing by 2. So I get 12x plus 3x plus 90 equals 180, or 360 rather. Don't forget to multiply that last one by the 2 as well. And then I would solve, so we get 15x equals 270, and x equals 18. Now I want to find y. Well, again, we know these 2 triangles are congruent, so these corresponding angles must be congruent, because I know that triangle CAB is congruent to triangle CDB, so angle A must be congruent to angle D. So I'm going to take my 18, multiply that by 6, which gives me 108 for y. Okay, number 5. In kite A, B, C, D, we've got diagonals, segment BD and segment AC intersect at E. If the measure, can't see that. If the measure of angle BEC equals x squared minus 8x plus 105, find x. So pause the video here. I'd like you to draw a picture, label your picture, and then solve it. And if you need to, go back to your property sheet that we did to figure out what to do for this. Or actually we wrote it, that one doesn't talk about the kite. We talked about the kite here. We labeled some stuff. So if you want to look at that, it might be helpful. So remember, you've got no parallel sides. You have your diagonals are perpendicular to each other, and the diagonals bisect the angles as well. And you can also figure out a lot of this by just finding congruent triangles. So then that way you don't have to memorize it all. All right, go ahead and try number 5. All right, so we should have a nice kite drawn here. A, B, C, D. You want to make sure that diagonal BD, the B and D are across from each other in AC. That might mean you might have to rearrange here. And we know BE, they intersect at E, and BEC. So this angle right here is x squared minus 8x plus 105 degrees. So what's true about our kite? Well, our kite has diagonals that are perpendicular. So I know that x squared minus 8x plus 105 equals 90 degrees because all right angles equal 90. If you weren't able to get that, pause here, solve it, find your possible values for x. All right, so we have an x squared and an x. Anytime I have an x squared and an x, I want to get it equal to 0, so I subtract over my 90. And now to factor this, you can use p's and c's. You don't have to because there's not a 1 in front of the x squared. So I'm just looking for two numbers that multiply to 15 and combine to negative 8. And that's 5 and 3. We want them to both have a negative sign, so they add to negative 8 and multiply to positive 15. Now set each factor equal to 0 and solve. So I get x equals 3, x equals 5. And then, of course, go ahead and check them. Make sure you get nice positive angles. And in this case, both of them will check. Number 6. As shown in the accompanying diagram, a rectangular gate has two diagonal supports. If the measure of angle 1 equals 42 degrees, what is the measure of angle 2? So here's your picture. So we've got two diagonal supports, and here's angle 1, and here's angle 2. Okay, so I would like you guys to pause the video here and try to come up with your answer for what is the measure of angle 2. All right, so I would start by labeling this as 42 degrees. I know, I just kind of start filling in things that I know. I know I've got opposite sides congruent to each other. I know the diagonals in a rhombus bisect each other. And I also know that diagonals in a rectangle bisect each other. And I know that in a rectangle, I also have congruent diagonals. That's really important to remember for a rectangle. So not only do they bisect each other, but they're congruent. So all 4 of these segments here will be congruent to each other. It's a parallelogram, so I know opposite sides are parallel. So maybe I trace my z here, and then I find, okay, well, this angle down here must be 42 as well. I also know that I've got all 4 right angles since this is a rectangle. So I could do 90 minus 42 gives me 48 degrees. So this is 48, over here is 48. I know that this triangle right here, actually all 4 triangles, since the diagonals are congruent and they bisect each other, we've got isosceles triangles. So this is an isosceles triangle, which means your base angles are congruent. So this angle over here must also be 42 degrees. And now I could look at this as a triangle and say, well, I know there's 180 degrees in a triangle. So I could do 180 minus 42 minus another 42 would give me 96. So that means the measure of angle 2 must equal 96 degrees. All right, we're going to do one more. Number 7. In the diagram below, quad STAR is a rhombus with segment SA and segment SA and segment TR intersecting at E. So here's some more info. ST is 3x plus 30. By the way, this is a regions question. SR is 8x minus 5. SE is 3z. TE is 5z plus 5. AE is 4z minus 8. And the measure of angle RTA is 5y minus 2. The measure of angle TAS equals 9y plus 8. And I want you to find SR, RT, and the measure of angle TAS. And here's the picture for you of your rhombus. STAR, and our diagonals are going to intersect at E. And you have all that information that you can label onto your picture now. So pause the video here, label everything you know, and try to find your SR, the length of SR, RT, and the measure of angle TAS. All right, so you should have found, hopefully, so we've got 3x plus 30. I'm just gonna quickly fill these in. 5y minus 2. Here's 9y plus 8. 8x minus 5 over here. 3z. 4z minus 8, 5z plus 5. All right, so the first thing I would do here is just kind of start marking some things. I know in a rhombus, all 4 sides are congruent. So that tells me that these 2 sides are equal, which works out nice because they both have an X in them. So congruent sides would allow us to set 3x plus 30 equal to 8x minus 5. And then you could go ahead and solve that, and that should give you x equals 7. Again, you should have the work on your paper. And if you substitute 7 in for SR, so 8 times 7 minus 5, that should give you SR is 51. So we found one of the 3 things we need to find. We also know that to find z, those are all diagonals. Well, what do we know about the diagonals? In a rhombus, the diagonals are perpendicular, but that doesn't help us find the lengths. And we know that the diagonals in any parallelogram bisect each other. So if the diagonals bisect each other, I could set SE equal to EA, since those are along the same diagonal and they all have just one variable. So again, solve for Z here. and you guys should have already done that. You get z equals 8. And I was asked to find RT, which is this diagonal over here. So now that I know z equals 8, I could substitute that in to find the length of ET, which gives me 45. But I want the length of the entire thing. Again, we know the diagonals bisect each other, so if I just double 45, that'll give me the length of RT. So RT should equal 90. And the last piece that we need to find was the measure of angle TAS, which is right here. So to find that, we know that I would focus on this triangle right here. I think this is probably the, so now I was saying that the angles here, all three angles, I'd focus on this triangle, and the number of degrees in a triangle is 180. Well, because we already mentioned that the diagonals are perpendicular to each other, I've used up 90 of those degrees. So, and again, I'll write diagonals perp to each other. And you'd also need to know the sum of the angles in a triangle equals 180 degrees. So I could then take 180. I've used up 90 of those degrees. So that leaves me with 90 degrees left for these two angles. So now I know 9y plus 8 plus 5y minus 2 would equal 90. Or you could set up one big equation, say 5y minus 2 plus 9y plus 8 plus 90 equals 180 for that whole triangle. Now you're just going to solve that. So combine your like terms. If you haven't done already, pause and go ahead and do that now. You should end up with y equals 6. And then to find the measure of angle TAS, you're going to do 9 times 6 plus 8, which gives us 62 degrees. And that is the last thing you needed to find there. Okay, so a long question, a lot of different properties you had to use there. So make sure you can do all of that on your own. Try it again if you needed to get help on this from the video. But really, really important that you know all of these properties and that you can use them here. A couple properties that would be really, really important to remember that you may not have known before is that the diagonals in a rhombus are perpendicular. So that allows us to use Pythagorean theorem. That one comes up a lot on the Regents exam. Also that the diagonals in a rectangle are congruent. That also comes up quite a bit. And that the diagonals in all parallelograms bisect each other. All right, if you have any questions, make sure you see me. I hope to see you soon. Have a great day. Pi out.